Okay, so like I was saying, this is the third session of Principles of Data Management. It's a theory-based session, so we're not going to be doing anything practical today, which is why it's booked in for a short amount of time. So we'll go through the slides, and at the end, then I'll show you the two documents in terms of assignments, and we'll talk through them, how you're going to meet the different criteria and things like that, and see how things go. Sorry, just got one person to add in. Okay, brilliant. Make a start.
Hello. Sorry I'm late. I was on the phone with my
No worries.
manager.
No, you're all good, Nathan. We're just starting the slides, so you haven't missed anything yet.
Perfect timing.
There we go. So criteria covered. So this covers 1.123, 2.1 and 2.5, as well as outcome 3 of principles of data management. So basically, if you're tracking all of your stuff on one file, by the time you've got these assignments today done, you should have, from the principles of data management unit, everything covered, outcomes 1, 2, and 3, except for criteria 2.7. And the only reason is because there's an assignment right at the end of the program where you'll cover it automatically, as long as you obviously, you know, the work's kind of good enough for the other criteria. It should meet 2.7 as well. So there's no point in you doing it twice. So that's why we do that. But yeah, should have everything covered except for 2.7. So if you're missing anything, then it should have been covered up to this point. You can obviously double check that and things. So these are the kind of topics that we're covering today. So we talk about scalability, scaling up and scaling out, data reduction, distributed computing, cluster computing, dynamic data models. So they're all stuff that comes up in the criteria. It doesn't say it on here as well, but there is a little bit on policies and legislation as well, because that's what the second sort of assignment is mainly based on. Okay, so starting with scalability then. So like it says on the screen there, basically it's the characteristic of an organization, a system, a model, or some sort of function that describes its capability to cope with and perform well under an increased or expanding workload. So obviously, when we're talking about scalability, we're mainly talking about scalability in terms of data, storage, and the capacity to kind of work with data. I think the kind of it's not necessarily trap because it's not really wrong, but I think what people kind of fall into the habit of is thinking of scalability as just storage, where it's also, if you're processing data, scalability applies to that as well. Because if your organization doesn't scale very well, if you're working with more and more data and that data is getting more and more complex, it's going to get more difficult to work with, and your efficiency is going to go down and things like that. So yeah, and like it says here as well, a system that scales well will be able to maintain or even increase this level of performance or efficiency, even as is tested by larger and larger operational demands. So I guess that's the key there, is operational demands. So that could be an operational demand could be storing lots of data. An operational demand could be, processing more and more data. It could be something completely unrelated to data, but obviously we're focusing on data in this apprenticeship. But that's the idea. A company that can scale well, more and more data is being used, data from different sources, different types of data, more complex data, things like that, and you can scale up your operation to work more efficiently with those kind of things. So yeah, like I say, main two things that we focus on because we are thinking about data is capacity and performance. So it's vital that you know the capacity and the performance of the system that you're working with. And it's kind of like, at a really basic level, we've talked in previous sessions about using something like Excel. If you use Excel with various different amounts of data, you'll notice that it works fine. Then when you get to a point where, normally it's around about the 100,000 rows mark, it starts to slow down, and then eventually it basically doesn't kind of work at all. But then, if you use something else, then it's going to work a lot better. So when we talk about scaling, there's two main types of scaling that we can consider. They're both sort of normally they're both sort of used in most organizations to some degree, but then obviously different organizations might have different preference on which one they go to and compare together. So vertical scaling, or sometimes it's called scaling up, is the process of adding resources. So it could be memory, more powerful CPUs to an existing server. So if you think about like a smaller organization, this is the type of thing that they might be using. Um, uh, I guess so. We'll just see in a moment if I've got the apologies. I've changed these slides recently, so I'm just trying to remember what I've covered where, so I don't end up going over things twice. But yeah, like I said, vertical scaling. So you imagine you've got your computer, or you've got a server in an organization. You can take that apart. You can add more memory. You can add a more powerful processor. So basically, you're scaling up the performance and the storage capabilities, and that's why we call scaling up, because you're focusing on one device by kind of physically adding. It might be additional hardware, or it might be um, you know uh, more up to date or more advanced hardware. Um, yeah, it could, like I say here, also mean replacing the entire computer to a new one with more CPU. So it might be that scaling up isn't just taking one device and adding more to it, but it could be that you're replacing a device with something more powerful. So if you've got a server the organization uses, and you need more memory, you need more performance, it may be a case that you completely scrap the server and get a new one in. So those would be examples of vertical scaling or scaling up. It's focused on hardware, and it's about replacing hardware or adding to existing hardware. That's generally how it works. Sorry, let me just go. Yep. So scaling out then is, well, I mean, the image kind of shows it quite well, but scaling out is where you, sorry, I thought I'd mixed up two slides then, but we're okay. Yeah, so basically it's where you add more devices to the network. So, you might have an existing server. So if you want to increase your capacity, it may be the case that you add on additional hardware and things like that, or it may be the case that you get a second server that can work with the first one, and so on. It could be adding multiple computers to a network, you know anything sort of like that. And that's, like I say, the distinction to make between vertical and horizontal scaling, or scaling up and scaling out, is vertical scaling or scaling up is taking what you currently have and kind of almost like stretching it out to make it bigger. So you add more things to it, or you replace it with something that's more efficient, things like that. Scaling out is you're just adding more things onto the system. So think about it that way. And I always get them mixed up, and lots of other people tell me they always get them mixed up as well. But if you kind of think about it, if you've already got a server and you want to make it, you want to increase the storage, you can add more and more things on top of it. So it's kind of like you're scaling vertically. Horizontal scaling, you're adding more devices to a network. So you're putting them side by side and you're scaling out. So that's how I kind of remember it in my head. I think about adding things on top is it goes up, so that's vertical. Adding things onto it, so to the side, then it's scaling out. Some of the pros and cons. I got this in as a task, but like I do with all the tasks, I'll give you a couple of minutes to have a think about it. If you want to come off the mic and have a chat about it, or if you want to if you want to give an answer in the chat, I always welcome that. But if you just want to have a little bit of a think about it yourself, you're welcome to do that as well. So I'll give, like I say, a couple of minutes for that. Have a think about it. Tell me what you think the pros and cons of each are, and then we'll have a little. I'll go through it afterwards if nobody wants to. Yes, Thomas.
It reminds me a bit of like if you had a shop, I suppose. So trying to increase your sales in that shop or open another shop. So scaling out would be opening another shop, whereas scaling up would be trying to increase your profitability of the shop that you've got. So there comes a point where you can't keep scaling up. It becomes like not achievable. So that's when you want to then scale out.
Yeah, that's it's a really good analogy, and it's one that I've used before actually to kind of help explain it. That's exactly what it's like. You've got a store, and you can so there's a like the example I always give is there's a shop that I used to go to. It's like a small sort of locally owned thing, um, and they had their shop, and then they wanted to expand, so they bought the unit next door, and they kind of tore down the wall in between them, and they moved into there. But and they did different things to give themselves more and more floor space, but eventually they got to the point where there was nothing they could possibly do to get more stock in that one unit. So they ended up, opening up a second store. So that's exactly it. Scaling up or vertically scaling is like Thomas was saying. If you've got one store and you know maybe you restructure so you've got more shelf space, or you buy the unit next door and move into there as well, and then scaling out would be like buying a second location. So yeah, really good way to think about it. Anything anybody wants to try and answer these two particular questions, or should I just go through a little bit? I'll take that as a go through a little bit. Let me just see. Yeah, okay. So basically, pros and cons of scaling up versus scaling out. So scaling up, the first thing, it kind of alludes to what Thomas was talking about there, where if we scale up, there is a limit. There's only so much. If you've got one server, there's only so much performance you can squeeze out of it. It's also quite time consuming and expensive to um, if you're changing the memory out of something, you need someone who's got those right expertise to be able to do that. I guess you do as well for kind of like scaling out, but in some instances, like if we're talking about just adding like an extra computer, that can be a lot easier than adding a computer to a system can be easier than changing the sort of hardware of an existing system. Um, but yeah, there's that realistic ceiling. Once you've updated the memory, you've updated the CPU, you've updated this, so you've updated that. There gets a point where there's not anything you can do anymore. So there is a realistic limit to it. Um, like I say, the other thing is with scaling up is it can tend to be quite expensive, especially today. I feel like every time I kind of go online, I'm hearing more and more about how different components are getting more and more expensive. So that can be quite challenging to do. I know, obviously, if you're scaling out, you're buying a whole new system, so that sounds like it'll be expensive as well. And then obviously this is all expensive because this sort of equipment just is expensive. But it's really when you get into kind of like the upper echelons of performance, does equipment start getting really, really expensive. So sometimes it might actually be cheaper to buy a whole new system um, uh, to go alongside the one you've got than to buy the kind of top end hardware for what you're already using. Um, so that's the one thing. Scaling out, then obviously, like I say, the pro of scaling out is that you can always add on something to the system. There's no realistic limit to how many you can keep on adding on. Or there is a realistic limit, but obviously it's far beyond what you can do scaling up one device. Like I say, in a lot of instances, it can be a lot easier to do because it might just be a simple case of adding a new device um, uh, onto a network. It's really good for companies that have lots and lots of employees, or maybe the number of employees is growing as well, because obviously, as new people join, it necessitates having new laptops and things like that. So that's another instance where scaling out can work really well. Um, you know, the cons of scaling out, it is a more difficult system to sort of manage. If you're working with one server and you're kind of updating it, that's normally whereas it might be harder to actually kind of upgrade than adding a device onto a network. The initial kind of setup of the network is the complicated part with scale out. So, it's a lot easier to set up one server and then update that server later on than it is to set up a whole network. So you need the right expertise and things like that as well. So like I say, they both have their pros and cons. They both have their place. What you'll normally find in most organizations is they use a little bit of a mix of both. If more storage is needed, or if more processing power is needed for certain tasks that are being carried out. It might be the hardware is upgraded and things like that as well, but then they also kind of, add a new server onto the system or add a new device onto the system of some kind. So it's rare that an organization will just pick one, use one, and that's it. It'll normally be both, depending on the circumstances. If I think back to the very first job I had, it was a small, it was a big company, but we were kind of like a small office within that company. So um, we were using one server in the office, and what would happen is every now and then we'd be told that the server's been updated, so additional hardware's been added or updated or such, and then at some point it got to the point where we'd outgrown the server completely, so we needed to get a second server. So that's an example of obviously even a small office needing to use both methods of scaling. On the importance, it's like I say, there's a few different aspects you can kind of look at it from. So first of all, it's a operational and efficiency sort of thing. So if your organization can't handle the amount of data that's coming in, and obviously as we know, because I talk about it all the time, the rate at which data is coming into organizations and the complexity of data is always sort of increasing, and it's more so now than ever. If your organization can't deal with those volumes of data, you can miss out on opportunities. So, we obviously use data to give us insights, make decisions. If you're not using the most up-to-date data because you can't manage it, if you're struggling with, like I say, working with the data that you have, getting the best out of it, those sorts of things, and other organizations are able to do that, you might miss out on opportunities because of insights that they've managed to gather that you haven't been able to because you're behind the curve on your scalability. So it can affect day-to-day operations. If you can't store data, you're not going to be able to use that data. If your processing power can't handle the demand of the tasks you're carrying out, then you're not going to be able to carry those tasks out, or they're going to take you such a long time to do that, again, you're going to be behind. It can also go over into like compliance issues as well. So obviously, a lot of organizations carry out data processing tasks that they need to do to stay within compliance. So, whether that's like a financial thing, or, if a lot of like public sector companies, I know, like, for example, working before in property management, things like reporting to like Welsh Water is something that was a compliance task. So if you're not scaling, or if you don't scale well, like maybe you can update things, but it takes you such a long time to do that you miss out on certain things. You might run over a compliance deadline and things like that. So it can have a real effect on how you sort of work. Scaling is generally something that organizations are quite good at because there's dedicated IT professionals working in pretty much every organization today where this is what they kind of focus on. But yeah, it's important to be aware of what kind of like the risks are. And those risks kind of translate into benefits as well. So obviously on the one side, I just said that, if you're not scaling well, you might miss out on opportunities. If you're scaling in your organization is fantastic, it might mean that you open yourself up to opportunities before anybody else does them. Because if you have this big influx of data, while every other company is scrabbling to try and scale to meet that demand, if you scale really smoothly and really naturally, then you'll reach those opportunities first. So it's really important you can. One, because it provides you an advantage in terms of seeing data sooner. Secondly, because like I say, you could run into those like compliance, potentially legal issues, and it's everything that we always talk about. Like maybe it comes back to the customer. If you are a sort of organization that works with clients, and your clients can't access things because you're struggling with scalability, that's gonna lower their sort of opinion of your organization. So that's something to kind of consider as well. Like I obviously won't say which one it is, but I used to use a bank, and it felt like every single time I tried to use the banking app, they told me that there was too much traffic, so I couldn't access it. And I got so frustrated with it, eventually I switched to a different one. So that's an example of where the issues that they were having with capacity impacted my experience as a customer, and to the point where I just rather kind of use someone else. So that's something to think about as well. So yeah, there's lots of reasons why it's important. It's not just those ones I've mentioned there. I'm sure there's other ones you can think of as well, but obviously those are the main ones. And it comes back to that sort of thing: is it impacts the way an organization operates. That's the main thing. And then if you impact the way an organization operates, that can have impacts on several different things: financial loss, uh, you know, um, missing compliance deadlines, impact on the customer, different things like that. So that's the kind of topic of scaling up and scaling out. So like I say, anybody got any questions about that, let me know. Otherwise, I'll move on to the next topic that we're going to talk about, which is going on to data reduction and a couple of methods around that. Okay, so data reduction then, like it says here, we collect data from various different warehouses for analysis. If you remember, a warehouse is kind of like the term for a database like management system across an organization. And it's difficult for data analysts to deal with large volumes of data, which is why reducing data is really important. We go through a couple of data reduction techniques, basically techniques we can use to reduce the volume of data. But the key is we want to maintain the integrity of data. So like I say, it kind of goes hand in hand with scalability side things. So, it's important that companies can scale to meet demand, but also it's important that you're being efficient with your data. And are you storing lots and lots of data that you don't need to be storing because it's unnecessary, it's duplicated, it's in a format where it's taking up a lot more storage than it needs to be, different things like that. And we can have a look at some methods around that. So one of them is thin provisioning. So it's basically a method of on-demand storage allocation, like it says here. So this is something that's normally sort of like cloud-based. So as you need more memory, you're able to access more memory on whatever sort of system you're using. And alternatively, if you do manage to free up space for whatever reason, then that space can be reclaimed for something else. So it's got several advantages. So number one is that, like I say, you're not using up any more data than you need. And normally you kind of pay per storage. So it can be much more cost effective because you're not paying for what you're not using. If you think about like a more traditional system, so this is, like I say, something that's cloud-based. It's normally like a service that you use. I'm sure at least some of you've used something similar, like whether it's like Google Cloud or was it Apple Cloud, or they all call them something different. But Google has one, Apple has one, so on, where you can kind of pay to use their storage. It's that sort of idea, and it's uh, uh, like I say, advantageous because if you were using a traditional method like a physical server, if you go out and you buy you pay for this hardware for a server, it's obviously very expensive. You get it all set up, and then you realize something changes and you only need a fraction of the storage space and processing power you initially thought you would need. You're kind of stuck with it at that point, and that's what you've got because you've already bought the hardware. If you're using thin provisioning, like I say, if your demands change and you don't need as much storage as you did before, you won't have to pay for that much storage because you won't be using it. So, it can be cost effective. So that's one thing. Uh, Another thing to consider as well, it kind of ties into what I just said, but it's the initial startup cost of this. If you've just opened a new office, you've just started an organization, something like that, it can be a massive investment getting all of the different hardware, servers, different devices, everything you need to connect up a network. it can be a big task. It can be really expensive to do. So thin provisioning is basically a way that you could have as much storage as you need from day one without having to make the massive investment of all of this stuff, because you kind of you pay monthly or something like that. And that's likely to be more expensive in the long run, but the startup cost is a lot less. So it's a really good option for some organizations. So that's the idea of thin provisioning. Like I say, most people are like I say, familiar with the idea because they've used something similar, like in a on their phone or something maybe. But yeah, and like I say, the image kind of shows there with traditional kind of allocation. We get our data sort of in there, and then these are kind of allocated and unused. So you have the data allocated to you. So like if you buy a hard drive, that data is then allocated to you, but it might be going unused. Whereas within provisioning, if it's not allocated, it's kind of like available storage. So whatever service you're using, that storage can kind of be used by someone else if you're not using it. But then that means that you're not paying for it then, if it's not being taken up. So yeah, that's the idea of thin provisioning. So that's method number one of sort of data reduction. It doesn't actually reduce the amount of data you're holding as an organization, but it prevents you or helps you not be paying for data storage or pay for capacity, sorry, they're not actually using. So that's that one there. The other one then is data deduplication. So it's the process where basically redundant data is being removed before data backup. It allows for storage of one unique instance of all the data. I think that makes sense. Within the database without any copies needlessly taking up space. Because there's lots of different software tools out there that can do it for you. And there's also programming languages that give you option to find and remove duplicates from data sets. But it can prove more difficult than using already built softwares. So like I say, you can go and do this stuff in, Python or something like that. But using a software that's designed for this specific task is always going to be slightly better. When we talk about data deduplication, the one thing to think about is, like it kind of says on the slides there, duplicates that you actually find within data sets. So do you have rows appearing multiple times, things like that? That can be a big one. Another one is having multiple instances of the same data set around an organization. And it sounds, some people say it sounds a bit silly, but it's surprisingly common. And I've come across it many times in my experience as well, where an organization will have multiple copies of the exact same data set being saved in their database for one reason or another. And that is what deduplication is as well. It's looking at those data sets and saying, we've got two of this one, do we really need both? That sort of thing. And it might not be a full data set, or it might be part of a data set, something like that. So one example off the top of my head, I can't remember exactly what it was sort of around, but we working with properties, had a database at one point where we had all of the different properties in it with lots of different information on them. And then there was, one particular team that needed to see information around, compliance on those properties. So what they had was the exact same data set, but just with the compliance information added onto the end. So that data then, or the majority of that data, is duplicated because you've got two data sets where one is you've got all this data, and then one is the same thing with just a few things added on. So what makes more sense for a kind of system is to just have the one data set, the one with all of the information in it, and then if somebody doesn't need that information, when they pull the data from the database system, they can exclude those columns, that sort of thing. And we used to use SQL. So as you know from the previous sessions, you can write out an SQL query that only pulls certain columns from the database. So it's nice and easy to do. But that makes more sense because that's one example. But what would actually happen is we'd end up with lots and lots of different, database system where we had lots and lots of different tables in there that were the exact same information, just with something extra added on. And then we've got another copy, but it's got slightly different details added on to the end, and so on and so forth, to the point where if you took the bulk of the data around properties, it was probably duplicated about 20 times. And it's just completely unnecessary. So it wasn't myself who did it actually, but somebody took on the task of deduplicating our data, so we didn't have all of that done. What made much more sense is one data set with all the information in there, and then if somebody wants to read off particular columns, then they can ask somebody to do that and using SQL, that sort of thing. So that's the idea of data deduplication. If you've got a table in your database that has the name of every single property that you have, do you need a second table that has every single name again? Because you're duplicating the data if that's the case. Or obviously whatever you work with. If you've got a table in your database which is all of your customers, do you need all of the customers again, but with one additional detail added on? Normally it's not the case. So what you would do is you would just have one and then, pull the columns you need. But then, obviously you do get actual duplicates within the data sets themselves as well. And, that's something else you can look at to kind of take out. I'm kind of going off the track of what you need to cover for this really a little bit, but just to kind of mention it, because it is something that you can write about in your assignment if you want to. You can look a little bit more into. There's an idea called normalization in data. A normalization is basically where you take a data set maybe, and you break it down so that it fits really nicely within a database system. And one of the things you often do in that is you take variables in the data set and you take them out and you use like a code instead. And what I mean by that is let's say you've got you've got customers, and all of those customers can be signed up to a different service. So in your data set, you've got the customer, you've got their name, their email, their age, different information about them, and then you've got what service they're signed up to and all the information about that service. And let's say there's 3 different services. In your data set, the information on those services is going to be the same. If somebody's signed up with service number 1, the information for that service is going to be the same every time. So if you've got 100 different customers all signed up to service number 1, the information for service number 1 is repeated over and over and over again. So what the way a lot of database management systems will work is, instead of having all of the information, they'll just have service code, service number 1, and then they'll have a separate table that just has each service in it once. So we can pull the information in because we have the service number ID or whatever in next to the customer, and then we can look in that other table to see what information that is, but we're not duplicating that information over and over again. And another example of this is the stuff we were doing last time with the joins in SQL. So if you think back to that, when we were working with, let's say we had our customer, I think customer number 1 was called Alice, and we were looking at what products that she'd ordered. We had a product code, but we also had a product name, a product price, a stock number. So instead of having, Alice, she's this old, this is what her location, so on and so forth, and then having, this is the product she bought, this is the product name, this is the price, and so on, in one big data set. What we had a table that's got Alice in it. We had an orders table that shows that she ordered product number 1, and then that data for product number 1 only has to exist in one place, because we can just read it in against everywhere that it says product number 1. So that's another example of where we use data deduplication, because by just having a product code that refers to another table, hopefully that's kind of making sense. Like I say, if that's a little bit confusing, let me know. But if you've got a table where you say product number 1 and then a separate table in SQL which just has the different products on it and their information, that's going to take up a lot less data than if every single customer has all of the product information printed next to them. Because like I say, if 100 people buy the same product, they're going to have that product information in the data set 100 times. Yeah, so that idea is called normalization. So just to mention it once again, I definitely recommend, like I say, if you're interested in SQL and data management systems and things like that, that you do a little bit of reading on normalization, how it works, the kind of issues it prevents as well. There's an issue in data called a transitive dependency, which is prevented by normalizing data. So yeah, like I say, outside the scope of what the apprenticeship covers, but recommended reading, I definitely say so. So have a look into that. But if you do have a read up on it, you can mention it in your answer to this question when we get into the assignment, because normalization is a way that reduces the amount of duplicate data that the company's holding. Because like I say, with those different things that it could be a product, it could be a service, could be anything. With us, it could be like a course, for example. Instead of having the information for that printed out multiple times, it exists one place in one table, and it's just referenced by a code. Takes up a lot less room. And as well, I got some examples of the tools to look at. So NetApp, Data Domain, and WinPure, sorry, are all examples of software that's specifically designed for data deduplication. So again, that's something you can go and have a look into if you want to know more about how they work. You don't really need to talk about them in terms of the criteria, but obviously, I know you're obviously on this course because you want to learn and you're curious about these sorts of things. So if you want to know a little bit more about specific softwares, you can go and have a look into these. So it kind of moves us on to a slightly different topic then. So like I say, if anybody has any questions about data reduction or any of the specific methods, let me know. But otherwise, I'll move on and start talking about distributed computing. Okay, I think that's all good. So distributed computing, there's a criteria in the assignments which looks at distributed computing and computer clusters and asks you to talk about both of them in one criteria. So we'll go over them both. So distributed computing is basically a model where components of a software system are shared among multiple computers. So pretty much every organization uses something like this these days, I feel. And if anybody works for an organization that doesn't have a distributed computing system, let me know, because I'd be curious to learn more about that. But pretty much every organization I can think of or I've been involved with has used something like this. But basically, several machines that can provide the same service. So if one machine stops working, another's available to do the job. What we need to kind of think about this is, I don't know if I don't know, like I say, how it kind of works with you guys, but for me, I've got a company laptop with ALS. But if I go into the office and I sign into a computer, I can still see all of my different files, all of my information, different things like that. Obviously, there are a couple of things I've got saved to the actual laptop itself, which I wouldn't be able to access. But I'm on the ALS network, so I can see everything I need to see, regardless of which ALS computer I'm on. So that's an example of, like I say, a distributed computing system that's over, like I say, multiple sort of locations. It's not a physical network. It's like I say, an internet or cloud-based network. But thinking back to that first organization I worked for, like I say, in the small office, we didn't have laptops and stuff. We had physical desktop computers in the office that we would come in and use. And no matter which computer I logged into, it would be as if I was on the exact same device. And that's because they're all connected physically to a server through wiring. So that's another example of a distributed computing system. But that would be a physical system because they're all connected by actual sort of physical wires. Then there's a physical connection there. And yeah, that's the sort of thing, like when I was working in that particular office, if I logged in one day and for some reason the computer wasn't working, I could just move one desk over and it would work absolutely fine. And there wouldn't be anything on that I didn't sort of have access to or things like that. I remember one time when I went in and my desk used to be right in front of a window and there was somebody repairing the window. So then, okay, I have to sit somewhere else this week. And I don't lose anything because I'm still on that sort of network. So that's the idea of a distributed network. Multiple devices, all being part of a network that can essentially, connected, but work independently then, if that makes sense. So in that network, I've got my company laptop, my manager has her company laptop, my colleague has his company laptop, and they're linked, but we're all working on our own thing at one time. So right now I'm delivering to you guys, but they might be doing something else. Like I said here, it requires concurrent components, a communication network, and synchronization mechanism. A distributed system allows resource sharing, including software, by systems connected to the network. So again, like I say, it could be sharing of files, could be the sharing of specific software, across the network. And there needs to be things in place to make sure that, like I say, you've got a synchronization mechanism. So when I do something, is that reflected on the network in a reasonable amount of time so that we can work together effectively and things like that. If I update my teaching materials, you guys will have a training advisor who you'll meet with, and they'll talk to you about your assignments and stuff, and they're using the materials that I put together to guide you on that. If I I'm changing those and there's no synchronization mechanism, or there's no concurrency there at all, then when they come to discuss the assignment with you, they're not going to be looking at the same documentation, which obviously causes issues. So those sort of things are important. Yeah, and then it's got lots of different things here. So we've got intranet, internet, and email, different telecommunication networks. It could be a network of branch office computers, information system to handle automatic processing of orders. It could be real-time processes as well, so things like aircraft control systems. I've got like electronic banking on there as well. And like I say, the distributed networks, I can go on my phone and I can check my bank balance and things like that. And that's because, by having access to the app, it makes my device part of that network so I can access it. Like I say, I'm sure pretty much everyone, is working for an organization that use some sort of distributed computing system. So if you're not sure, just have a think, is there a way that you can kind of share files without emailing them, but do you have access to a shared location with anyone? Can somebody else kind of log into their work account on your laptop if they wanted to? Those kind of things. Whether it's a cloud-based network or whether it's a physical network, pretty much every organization is using this at the moment. Another idea that we talk about then is cluster computing. So cluster computing is a similar sort of idea, but there's a slight difference. So a computer cluster is a single logical unit consisting of multiple computers that are linked through a LAN. Recently, I should have updated this slide, I'm just realizing, but somebody asked the question about, they gave me an example and they talked about where a cluster computing example where they weren't connected by LAN, and they asked, does that still make it a computer cluster, or is it different because they're not connected by LAN? And the answer is it definitely is, but typically they are connected through LAN. That's the most common way, but it is possible to do it other ways. So I'll talk about it a little bit more in just a moment. I'll come back to this. So the network computers essentially act as a single, much more powerful machine, and they provide faster processing speeds, larger storage capacity, better data integrity, superior reliability, and wider availability of resources. So we're not comparing two completely different ideas here. Cluster computing is a type of distributed computing system. On a typical distributed computer system that, like I keep on saying, pretty much every organization is using. There's different devices, they're all connected, but those devices are all working on their own task. So for example, I'm connected with the other computers in my organization, but they're not all doing the same thing that I'm doing right now. And maybe there are times where two people in an organization are working on the same task, but it's not it's not the explicit intention. Then what makes cluster computing different is you'll have a group of computers that are joined in such a way that they're basically acting as one computer and they're all working on one task at a time. So typically they're used for tasks that need really like really high levels of processing power and things like that. We can go through a couple of examples of those in a minute. I think I got them on the next slide. But that's the idea to remember. It's not necessarily about them being physically connected or not physically connected, although they are typically physically connected. But the key is what are all these devices on this network doing? Are they being operated by different people doing different tasks, or are they being operated by maybe one person or one team of people all to work on the same task at the same time? So same task at the same time is a computer cluster. Different tasks, different people is a more general sort of distributed system. Okay. I got a slide on there, and like I say, do some research. That's so something that you can, have a further look into when we do the when you do the assignment. I just want to make sure if I had the so to go over a little bit more. Sorry about some of the examples. So when I give you the assignment, I will remind you that one of the things that we're looking for is for you to talk about the types of organizations that might use a distributed network and the type of organization that might use computer clusters. So computer clusters, when I say tasks that need really high levels of processing, it's typically things like really large machine learning algorithms, big AI models, different simulations and things like that. So I've seen computer clusters used in the aerospace industry for simulating different events and things like that. I've seen them used in healthcare for machine learning models around detecting different sort of diseases from scans and things like that, different health conditions. So it's those types of things. It's massive amounts of processing power needed to focus on one task, typically machine learning or simulation based. Those are the main two I find that come up when people are talking about computer clusters. So because of the nature of that type of task, typically it'll literally be, however many devices, it could be, 20 computers or something, all sitting in one single room, all connected physically, and they're working on this massive, massive task. So that's why, previously I had in the slides that they're all linked through LAN. It is possible to have computer clusters that aren't physically connected. It's much rarer, but it is possible. So just bear that in mind. That it might be the case that this what happens. But yeah, hopefully that kind of makes sense on computer cluster computing. So type of organizations would use it would be sort of people doing lots of research, so medical related research and things like that, or it would be big sort of AI based companies, machine learning companies doing machine learning, things like that. So that's the distributed networks and cluster computing. Like I say, there is a specific criteria on that. So we'll talk about it when we talk about the assignments. But again, if anybody wants to ask a question about those two ideas, let me know. Otherwise, I'll just move on to the next thing, which is looking at the different dynamic data storage models. And I think after this one, we'll have a bit of a break because that covers the sort of, as I said, the assignments in two parts. So this is part one covered then after this one. Okay, let's assume that's all okay. So dynamic data storage models. There's three that are covered in the criteria. They're named specifically, so you need to comment on these when you do your assignment. It's network attached storage, or NAS, object-based storage, and hyperscale storage. The one thing that's important to note about these is they're not completely separate ideas. You could have a network attached a network attached storage that's also object based if you wanted to, or you could have hyperscale storage that's object based. So a network system can be both of these things, two of these things at once. It would be difficult to have a network attached storage that's also hyperscale, but I don't know what the best way to explain it is. They're not necessarily different. They are. You can't have both at the same time, and I'll explain why. But it's like theoretically possible, I guess, is the best way to explain it. So yeah, I think that's what I see when I read the assignments from these for my own learners. Is I see sometimes that they'll get confused and try to write about it in a way that suggests that they're completely different things. Like something, if it's an object-based storage, it can't be hyperscale, but it can be both at once. So just wanna make sure I mention that so you can bear that in mind. So start with network attached storage, and basically, NAS is a storage device connected to a network. It allows storage and retrieval of data from a central location for authorized network users and varied clients. So think about that example I gave of that office that I used to work in, a small office. So basically, we had a centralized server in the office, basically, that would have used one of these network attached storage. So if I save some data, let's say I save an Excel file on my desktop, I can log into any computer in the office and that Excel file will be on my desktop. And the reason is because when I save it, it's being saved in this network attached storage. You've got the different, I might save it on this computer here. It saves to this network attached storage. And then when I log into this computer over on the other side of the office, it'll pull it from that network attached storage device. So, everybody in the office is connected to the same data storage unit. So we can all save data on there and we can all pull it regardless of which computer that we're on. And also what it allowed us to do, it meant that if I saved something, somebody else could open it from their computer because they're physically connected through one of these devices. So that office I keep on talking about, it was in insurance, and we used to share information on our different clients with each other. So we had one centralized spreadsheet. We could all open it up and add things to it, and the spreadsheet is saved here. So any device can access and open that spreadsheet and add things to it, and so on. So that's basically what the idea is. Like I said here, it's like having a private cloud in the office. So rather than it being like I say, something you connect to via the internet, it's something you connect to via physical connection, and it's typically seen in small offices. So if you think about, like, if you go into like your local solicitors or something like that, or a estate agent or something, on a high street, there's normally 5 or 6 people working in there. This is the type of thing that I expect them to be using, is something like this. In the office I was working with, it was a lot more people than that. It was probably just over 100, but it was still small enough where we could use a much larger network attached storage device than this. We could use that sort of thing. So yeah, those are the types of companies that would be using it. It would be either a really small company working out of a small office, or it might be a larger company, but where they have single isolated offices, they use these smaller systems. Yes, Helen.
So that's completely different to something like a SharePoint. Is that cloud-based SharePoint?
Yeah, so SharePoint
Right,
is cloud-based, or at least typically it is in, I don't know if it has some of the capability, but yeah, so SharePoint's cloud-based, so obviously, you kind of put things on there and they're accessible by your colleagues and things, but through the internet, basically. But this would be different. It would be, like I say, a physical connection. So there would be no way for me to get the information from this via like an internet-based connection, if that makes sense. Obviously, like in today's world, it's a little bit more complicated because, I gave the example just now of like an estate agent. So, if I walk down the sort of the closest sort of street to me, there's a couple of estate agents on there, but they obviously have branches in other places, and they probably need to communicate with each other in some way. So they might have to have some kind of hybrid system. But yeah, a smaller office, I'd expect them to be using something like this. And if you think about, like I say, a big estate agency, even though they've got lots of different offices, each of those individual offices is generally quite small, and they deal with their own stuff then, if that makes sense. So they can generally still use a system like this. And that's how it was for us with the insurance company, is even though it was a big company, everything that office did was all self-contained. So all of the kind of clients, their entire journey would be just with that office. They wouldn't have to deal with any other kind of office or branch and things like that. So we could use something like this to store the data and things like that. Yeah, and like just to note as well, it's faster, it's less expensive, and it provides you all the benefits of a public cloud on-site could. And it gives you complete control. So if you were using like a public cloud system, something like SharePoint or something like that, it's not going to be as fast as this. It's probably going to be more expensive, but then obviously, the downside is it's limited on how many people can use it because it is a physical device. It kind of suffers from the issue of what's realistic in a physical space then, if that makes sense. So this wouldn't work for ALS, for example, because ALS has a sister company, ACT, which we work with really closely, and ACT spread out over multiple sites. So we can't make a physical connection with a different, the main sort of office, Ocean Park House. Like if I'm there one day and then the next day I'm in the location on Hadfield Road, if I log into a computer there, I'm not going to be able to access the same information using something like this because we can't make a physical connection across the two offices. It'd be just being practical. So the next topic to talk about then is the idea of something called hyperscale storage. So like I say, here as the name implies, it's all about achieving massive scale in computing, typically for big data or cloud computing. So it's an infrastructure that is designed with the sole purpose of horizontal scalability as quickly as possible. And so, as you can see in the image there, it'll be lots and lots of different servers. They all connect to a load balancer, and then those will all connect to different sort of devices, typically through the internet. Earlier on, I mentioned that like in theory, a network attached storage can be hyperscale storage. The reason that it's typically not the case is because with hyperscale storage, it's dealing with masses and masses of data coming into the system at a very quick rate. And if you've got devices physically connected, that's usually not happening. Usually to have that many devices feeding information into new hyperscale storage, it has to be some kind of internet connection. So something to think about like this is, a big, really large organizations, streaming services, could be social media, things like that. I always think about like Instagram, where they must get, I don't know what the number would be, maybe that's something I can look up, but they must get thousands, maybe like hundreds of thousands of photos uploaded every minute onto their platform, and those all need to be stored somewhere. So they would have a massive hyperscale storage system where if there's some kind of big event and all of a sudden everybody decides they all want to post in one go, that their system can scale to meet that sudden influx in demand. They're not going to be caught out of that sort of thing. Or the other one I think about is something like Twitter, or it's called X now, where when the World Cup's on at the moment, if something exciting happens in the World Cup, everybody gets out their phone to tweet about it. So can this hyperscale storage system meet with that massive influx of demand? That's the idea behind the hyperscale storage system. Is you have tons and tons of data coming in, at a really fast pace, and then all of a sudden something could happen that means that pace increases even more, or has like a sudden burst or something like that. So that's the idea. So yeah, generally companies use it, like I say, social media. Excuse me. Something like Netflix. Obviously, if I guess like maybe like The one I think about is like Stranger Things. Obviously, people were really excited for the final episode to come out and things like that, the season finale. So, when that gets released, they can expect a big influx in people logging into Netflix to go and watch that and streaming it. So, you know, if demand can be really volatile, it can increase or decrease really rapidly, or if demand is just always extremely high, like in the case of something like Amazon getting loads of orders, people uploading pictures and text posts and videos and things to Facebook constantly, a hyperscale storage system that can rapidly scale to that demand. I've just realized I forgot to mention it, but if I go back a little bit, the kind of overall topic here is dynamic data storage models, and I guess it'd be helpful just to kind of explain what that term means really quickly. So a dynamic data storage model is basically a storage model that is built with the idea of scalability in mind. So it can be adjusted. It's designed in a way that it's easy to do that. So network attached storage systems are a dynamic storage model because you can always add another one of these little boxes onto your system. Hyperscale storage because you can always build more servers would be an example of a dynamic storage model. Object-based storage is a little bit different then because it's not a storage system in and of itself. It kind of ties into it's more about the type of data being stored. So basically, we talked about this last time, the difference between structured and unstructured data. Object-based storage is the typical sort of storage method for unstructured data. So, like it says here, it essentially bundles the data itself along with metadata tags and a unique identifier. So if you remember last time, I gave the example again of, I just realized I mentioned it a second ago, but I gave the example of Netflix. So if you imagine Netflix, they've got a load of video files, on a system somewhere in their database. You can't search those, or you can't order them or organize them or analyze them if it's just the video file. But when you go onto Amazon, go onto Netflix, sorry, you can click on the action category and see all the action films. And the reason that works is because all of those video files are given tags or metadata tags, they're sometimes called, where the metadata for, I just mentioned Stranger Things will be, what genre it's in, when it was released, what episode series, what series is a part of, what episode is it, who did I say who acts in it, what genre it is, those kind of things as well. So that'll be all the metadata around it. So if I want to go on Netflix and I want to watch a movie with a particular actor in it, I can type in the actor's name and it'll show me all the movies that he was in. Or if I want to watch a movie in a certain genre, I can do that. Because I'm not actually organizing the video files themselves, I'm organizing the metadata that's associated with those video files. And so that's what an object-based storage system is where we can store unstructured data using the metadata tags and retrieve the information we want to sort of that way, then if that makes sense. So like I said, it's customizable. You can input a lot more identifying information for each piece of data. So you can make sure the different tags and things like that fit around it the way that you need it to. The objects are normally stored in a flat address space, which makes it easier to locate and retrieve your data across regions. What we mean by a flat address space is it's not tiered. Oh, sorry, excuse me. Just give me one moment. I think I just need to grab a drink. Okay, I realized I did make myself a drink this morning. It was just the other side of the room. Yeah, sorry, like I was saying there, when we talk about a flat address space, the data, the way the data, so it's not tiered or structured. So whatever you need to access, it's not you're not diving through different folders and things like that. And a prime example of this, the reason I've got this example on here is because we used to teach this as part of the apprenticeship. The criteria has changed now. is the idea of Amazon Web-based Services function S3. So S3 is an object-based storage platform. Definitely recommend you have a look into this one as well. I know there are some organizations now which are moving over to using AWS and the S3 function as their primary sort of data storage methods. But yeah, you can set up, you can save data on there as objects, and then you can give those objects different characteristics. So you can search for the characteristics if you can't identify the data itself. You know, like a particular video file. So I gave examples of Netflix and I gave examples of Instagram and Facebook for the last one. So for object-based storage, those would all be examples again, because even though they are hyperscale, they're also object-based because they're storing pictures, they're storing videos, they're storing different things like that. So um, uh, if you're trying to think of examples of object-based storage, just think of any organization you can think of, which is likely to need to store a lot of videos, a lot of pictures, a lot of text posts, a lot of emails, things like that. And they'd all be examples of systems using object-based storage. Okay, so that's those three examples, the dynamic data storage models. Again, we'll go over the criteria that relates to this one. So if I believe we move on to kind of like the second half next. Yep, that's right. So we'll take a little bit of a break there, I think. 15 minutes like we always do. Or given that it's 10:43, if we just say come back at 11, and then we'll go from there. And like say, if anybody wants to hang around and ask a question or talk about anything I've brought up, then feel free to. That's absolutely fine. But otherwise, I'll see you in a minute. Okay, it's 11 o'clock, so we'll carry on with where we were. So the second half, like I said, I don't think it'll be quite as long as the first half. So we've got some more theory stuff to go through. Then we'll bring up the assignments and we'll just talk through them, make sure that you understand what all the criteria is, how you can go about addressing it, and things like that. The second part of this assignment is looking at outcome 3 of the unit. So if you're looking, if you have a look at your units in one file or whatever, if you maybe look at them on a guard's website, wherever the easiest way for you is, you'll see that they have the different outcomes. So outcome 3 is all around legislation and regulations. Let me share my screen really quickly so you can see the slides, and different policies and procedures and things like that. So yeah, so like I say, lots of things to go over, but it is really important. Obviously, I'm sure all of you are aware how important data protection is, being in the types of roles or working for the types of organizations you work for. But we'll go over a little bit of information just to kind of set you guys up to make it as easy as possible for you to address the criteria. So first of all, like I say, there is a question about the different legislation and regulations that are in place. There's lots of different regulations, like it says here. But a couple of examples I've given is the Data Protection Act. So obviously, Data Protection Act, controls how your personal data is used by organisations, businesses, or the government. Works alongside the General Data Protection Regulation as well. You could note, and you've also got things like the Freedom of Information Act. So it was passed to create a general right to access of all types of information held by UK public authorities about you. So, in the past, I've worked for companies that work closely with public authorities, and there are times where we'd have to request information from them, and it will be something they'd have to provide because it was based on these, personal data or identifiable information and things like that. That's just 2. There's lots of others as well. So, like one that I recommend that you look into for this assignment is the Computer Misuse Act. So the Computer Misuse Act is the one that defines, that unauthorized access of a computer is a cybercrime. It also goes into things like malware and those type of thing, like malicious attacks on devices being crimes. But there's lots of others as well. Sometimes a few people in this one have written about the I think it's called the Official Secrets Act or something similar. There's also maybe it's not fully focused on data and IT, but it might be really relevant to your organization in particular, things like environmental information regulations and things like that. So there's lots of different ones. You can go online, you can find a list of them all. And what I'd recommend for you is when you write out your assignment, you choose legislation that actually relates to your organization or your role. I think, for example, that one I mentioned, the name of it is just slipping me, but I think it's the Official Secrets Act or the Government Secrets Act or something. It applies primarily to government related roles and things like that. So if that's nothing to do with what you do, and maybe avoid that one. But if there is another legislation that's particularly relevant for your role in your organization, that's something you kind of want to look into. If you want to look into ones around financial information and you work for a financial organization, that's a good idea as well. Obviously, everybody kind of falls under the more general ones like computer misuse and data protection and things like that. But if there's something that's specific to you, definitely use that to your advantage because, again, it shows the awarding body that you understand how these things relate to your role in your organization, which is exactly what they're looking for. Talking about legislation and regulations then. So the criteria, what it's actually going to ask you to do is talk about how these different things impact your role. So we'll go through this again when we look at the actual assignment. But when we're looking at like the Data Protection Act, for example, tell us what the Data Protection Act is, but also write about what do you have to do in your everyday role because of this legislation, and things like that. And a really easy one is, like I say, the Computer Misuse Act. Things like, all of our laptops are password protected, I would assume, on this call. And the reason is because unlawful access of that computer is a cybercrime. So if I, it's kind of like it's illegal to break in someone's house, so everybody's got a lock on their door. It's the exact same sort of thing. So you want to protect your device from somebody potentially committing a cybercrime, so you have a password on there. So having a password and good practice around that, two-factor authentication, they're all things that impact your role as a result of the Computer Misuse Act. And it'll be the same with like the Data Protection Act, because the Data Protection Act dictates how your information can be used, like in here. It dictates things like how long that information can be held for, and those sorts of things as well. So like I say, I've worked for organizations in the past where information has to be deleted after a certain number of time if the person no longer works with us anymore. And so that is something that we have to monitor, keep on top of, and carry out, all because of this legislation. So like I say, think about what it is, but go a step further and actually think about how does this legislation impact my role. And that is why I say that you should try and pick things that are relevant, because like I say, if you pick something that's related to government roles only and you don't work in a government role, it's going to be hard for you to explain how that legislation impacts your day-to-day role. But obviously, if you pick something that's completely relevant, that's going to be nice and easy to do. So we'll go over that one in a minute. As well as legislation, there is data governance policies. So again, every organization will have data governance policies, and there'll be policies that outline various different things around data. Some of these things here, I've just realized I'm going off the page there. But yeah, things on data quality, data access, data security, retention and deletion of data. And like it says up here, they're basically there to ensure that assets are managed consistently and they're used properly. It helps stay within that legislation I mentioned on the last slide, and those sorts of things. So you're trying to avoid any kind of, maybe something like a data breach, or maybe something like data going missing and things like that. Because if everybody is doing everything within the policies, you should vastly limit the number of incidents or issues that potentially happen and things like that. So I've got some slides on the different types of policies, and then talking through the types of things that they would you'd kind of expect to see as part of them. So you'd expect them to include things like that they're to ensure information is of high quality, that is valid, that is reliable, and that is fully embedded in different services across the organization and things like that. Being more specific, for things like data quality, you'd expect it to define what the data quality process actually is. How often is that data quality process carried out? Who's responsible for ensuring data quality? Those are the kind of things. So the question in regards to policies, I think is a six-parter, which sounds like a lot, but it's not too bad to answer. But it's all around what you would expect to see as part of these policies. So think about those things. If you have a policy in your organization for data quality, what do you expect it to outline? So like I said, I expect it to outline things like, that the information needs to be high quality, accurate, and so on. But I also expect it to tell me who's responsible for that. If I open up my organization's data quality policy, I expect to be able to find the person that I need to speak to about these kind of issues in there, if that makes sense. Or I expect to be able to find how often that process is carried out, what the process is, those sorts of things. Yeah, and then, like I say, things like this here, these are more like end outcomes, providing and publishing data which is reliable, timely, and robust, being able to respond effectively to service provision and quality of life issues affecting our communities. So you can talk about that as well, what the kind of policy ensures then, if that makes sense. So what's included in the policy? What does it kind of outline? So, I'd expect the policy to be along the lines of, this is what the data quality process is, this is how often it's carried out, this is who has to do it. But then also, what does that policy ensure? So it makes sure that the data that we're using is always of a high standard, it's accurate, it's high quality, that it's robust, it's delivered in a timely manner, all those sort of things. and then it's going to be the same for all of these different types of policies, but I'll go through them all. So it's the same with access. So like I say, data access, access to data will be, as broad as possible. Normally with data access, data is classified into different kind of like categories. So you'll have data that's really sort of confidential, really private data versus data that's it's not to the same sort of standard. And then depending on how sensitive that data is, the policy will define who then has access to that data, who's responsible for it, and those different sorts of things. And it's kind of like I mentioned in the last session that we had, because most of you guys on this call aren't my learners, I can't access your information in the system. I can't go and look up any details on your one file or anything like that. And so that is because in our data access policy, it outlines that training advisors and tutors should only be able to see information on learners that they are training advisors for. And so if I'm not a training advisor for you, I can't see any of your information. So those are the kind of things I would expect a data access policy to outline. Who can access what, how is different data classified, and who has access to each category, and who's responsible for ensuring that proper access is given, and different things like that. There has to be a mechanism in place to make sure that if I call IT and I say, can you give me access to, person X's information, that they won't do that, because and it's obviously it's a genuine request. Like I say, most of you guys on this call, I have no reasonable cause to access any of your information, as of right now. So if I call IT and ask to be given access, or I contact a line manager and ask to be given access, is there a mechanism in place to make sure that they're gonna say no, or they're gonna raise that request rather than just give me the access? So that is what the data access policy will outline, is if I ask, that people will check with the right people and they'll confirm that I need that access, not that I'm just randomly asking for it, or asking it for some purpose that I shouldn't be accessing it for. So those will all be things outlined in a data access policy. Data security then. So again, like how we secure our data. So it should include details on how customer data, employee data, intellectual property, things like that is handled. So it could be password policies, it could be emails, it could be acceptable use. So all of this will be sort of included in a data security policy. So, again, using my role as an example, we hold data on you guys as our learners, as our clients, essentially. And so how do we make sure that your data is secure? So, we have a policy at ALS that'll outline all of the different steps that we need to take to ensure that your data is secure with us. So again, it's things like, devices being password protected, two-factor authentication on different things, and stuff like that. And obviously, something like one file that's got, more personal information attached to it, will need a higher level of security than like, on I've got data sets on my desktop which I just use for teaching. They're not at any sort of risk or anything like that. So, my password, my computer itself is obviously protected, but if someone did get in, they'd have no problem accessing those data sets, because it essentially doesn't matter if they do. But obviously, there'll be second and third lines of protection for more sensitive data, like our clients' data, that sort of thing. Same with emails as well. Like when we're sending emails, if we were, it's not something that I do, but if we were sending, I've got things like here, like a phishing, but if we were sending sensitive information, we need to report to the Welsh Government and things like that. We need to make sure our emails are encrypted, that they're sort of like password protected, they're not being sent to the wrong person, different things like that. But yeah, and it just tie over into kind of like phishing and those kind of things. So that'll all be outlined in the policy. It's not something I ever need to do, but if I needed to send information on my learners to an outside source, say Welsh Government reporting on it, or to the awarding body, what is the process that I need to follow to make sure that that data is protected? It'll all be outlined in the policy. So it'll say that you need to make sure your emails are encrypted, it needs to be password protected, you need to do this, that, and the other to confirm the email address is genuine before you send it, and different things like that. And then, yeah, like I say, also acceptable use. So, the information that we do have access to, are we using it for things that it should be used for, or is it being used in ways it shouldn't as well? So it'll outline what acceptable uses of, so again, using my role as an example, your data on the system, the policy will outline this is acceptable use of the data, this is an acceptable use. So, everybody knows what acceptable use is. Data retention and deletion, so touched on it a little bit earlier, but basically it states how an organization goes about storing data and deleting data in accordance with different guidelines. So there's various things that we might do with learner data. It could be archived, it could be retained on the system, it might be deleted after a certain amount of time. So what we'd expect the policy to outline again is first of all, what is the process? What happens with different data depending on the circumstances? So, for example, just because you finish your course, it might not mean that we necessarily it's the best idea to get rid of your data off the system, because you might come and do another thing with us later on, and that sort of thing. So it all sort of depends. It actually wasn't in wasn't related to data analytics at all, but I did a apprenticeship about 6 years ago, I think it was, with ALS before I worked here, and like my learner account is still on the system, because when I did another qualification when I started here, I could use the same one and that sort of thing. It'd been archived, but still there to access if I needed information on my my qualification and my teachings and things like that as well. Because like I say, there's information that's appropriate to delete and get rid of, but there's information that you want to hold on to. If a previous learner comes back and they want to know the details of the course they undertook, we should be able to provide that to them. So the data retention and deletion policy will outline, what data needs to be archived, what data needs to be deleted, what data needs to be retained for a certain amount of time, how long is that time, what happens when it hits the end, who deletes the data, what's the process followed when deleting that data, do we need to let anyone know before we delete it, or can we just go ahead and delete it? All those kind of things will come under the policy. And also, again, who's responsible for that? Whose job is it to make sure that we're archiving the right data, that we're retaining relevant data, that we're not deleting things that we shouldn't be deleting, and things like that. So again, things like who is responsible for it, how often it's done, how long it should take, things like that, pretty much should come up in all of these. And then the backup policy, similar in a way, but a little bit different. So backup policy consists of things like, identifying critical data and systems that need to be protected. So do we need to back up all of our data, or is it just the most important stuff? So again, I'm not involved with the data backup policy at setting that at ALS, but obviously things like, again, my Python data sets for teaching sessions, they don't need to be backed up, because if they go, it's all data that's either publicly available or that's been generated for example purposes. So it wouldn't be difficult for me to recreate it if I needed to. But obviously data on learners, it's really important that that's, on progress and things like that. It's really important that that's backed up, because if we lose that, we don't know where you are in the course and things like that. Your evidence needs to be backed up, because we don't want to lose the evidence that if you've put all the hard work in and you haven't kept a copy of it yourself and we lose it, then that's going to be a problem, isn't it? So that's it. They'll clarify what data needs to be protected, what type of backup will take place. Is it going to be a full backup? Is it going to be a partial backup, incremental backups, these different things? How often does data need to be backed up? Is it like a once a day thing? Is it as and when things change? Could be any of them. And also what the restoration procedures are. So if there's an incident that occurs and data's lost, at what point do we start the restoration process? What is the restoration process? Who's responsible for restoring the data? And all these different sorts of things. And when I say like who's responsible, just to kind of be clear, it might not be like sort of one person necessarily. It might be that everybody's kind of responsible for it. If we think of data security, for example, I would expect a data security policy to outline, you know, who is responsible for certain data security measures, but the answer might be that everybody is responsible for making sure that their laptop is password protected and that their emails are encrypted and things like that. So that's what we'd expect to see in that policy. So I think I've got, I think this is either the last one. I've got one more after this. So like I say, those are the different types of policies. Those are some of the main ones, and those are the ones that I think are going to come up in this, because I can't remember them off the top of my head, but it'll come up in this assignment. But like I say, what the criteria is focusing on is what you would expect to see in these policies. So think about think about that question. If you're looking at your, let's say again, it's data access, your data access policy for your organization, what do you expect it to define? And I'll give you a couple of ways you can answer this. But like I say, you can talk about things like, who's in charge of data access, what data can be accessed by who, what counts as sensitive versus non-sensitive data. You'd expect the policy to define all of those things or include all of those things. The last one then is there is a criteria on data being up to date. Policies and procedures being up to date and widely publicized. So it's kind of it kind of goes without saying, but it's all well and good having these policies to define how people work with and use data in your organization. But if the policies are outdated, or if nobody knows what these policies are, you might as well not have them because they're not going to be followed. So it's important to have good policies in place, but not just have good policies in place, but make sure that people actually know what these policies are. People know where to access them. People know how to use them, and different things like that as well. And obviously, if they're updated, if things change, that those changes are reflected. So, like I says, older policies might not be compliant with new laws. Laws do change, regulations change, different things like that. Maybe it's a change in the services you're offering, which now means different laws apply to you than before. So, it can spiral into problems like fines, loss of customers, things like that. Potentially even legal issues if it's a case of negligence, if your policies aren't up to date. And again, if policies don't know about the new policies, they can end up making bigger mistakes for the organization and potentially lose their job, or the organization might face problems, and it's just because they weren't informed about a new policy or a policy change or things like that. So the one I'd have to think about for this is, how does your organization make sure that you're aware of the different policies? Is there training on this sort of stuff? Do you have information security training? I'm pretty sure everybody does to some degree. If a policy changed, how would you be made aware? Would it be like a meeting? Would it be an email that gets sent out? Those kind of things. And have a think about as well. Do you know where to access your policies? Like, how easy would it be for you to find the policies and all these different sort of things? So, I know a lot of companies work the same way, but for us, we have a SharePoint, and I know that all of the different policies are on there. So if I wasn't sure about something regarding data protection, I could go and read the policy, and also the policy could point me in the direction of people who could provide further information on it and things like that as well. So have a think about it. What's the case for your organization? How would you access your policies and procedures if you needed to? And are you kept well up to date on them? Do you get emails about it? Do you get training on them and different things like that as well? So that's all also very important stuff. The last thing I'd say is obviously it does depend on the organization whether sometimes it's really important that it's the employer's responsibility to go and read those policies. Sometimes the employee will have more of a push to make sure that people are reading those and understand them and things like that. So that's that kind of last point there. So I think this is the last slide, but we'll see if there's just one more after. No, I was right. That was the last one. So that's the content covered today. So what I'll do is I'll get, like I say, those 2 assignments up, 2 separate assignments, or part 1 and part 2, whichever way you want to look at it. And we'll just talk through what you need to cover in them. I know it's a lot to have 2 assignments and there's a lot of criteria in them, but like I say, you've got all the way up until September to do these. And once you get the ball rolling on them, they're really not that bad. I don't think, at least anyway.
Yeah, thanks, Lloyd.
So let me just see if we get part 1 first. Okay, and you'd be glad to know I've be a little bit less confused in this account because I've double checked beforehand to make sure I've got the right version of the document in front of me with all the changes made to it. Okay, so this is the first assignment document. So this is the it's called P1 Part 1. It's covering these 5 criteria. This is 1.1 to 1.3, as well as 2.1 and 2.5 for principles of data management. I'll read through the questions below to kind of give you an idea of what to do. So to cover 1.1, you need to evaluate why you think scalability of capacity and performance in data storage is important. So again, focusing on the actual criteria, make sure you're first of all evaluating. So when we talk about evaluating, the easiest way to think about it is to think about it from different perspectives. So the second part of this then is that we're looking at the importance of scalability and capacity. So, tell us why it's important to scale. What are the advantages of an organization that can scale really well? But also you can talk about, the other side of the coin. So what are the negative effects of not scaling well? Maybe what are the challenges to scaling? Obviously, being able to scale well is expensive. It requires a lot of technical know-how and things like that. So those are obviously barriers to being able to scale. So you can talk about those as well. But yeah, that's it. Like I say, I think with these criteria, the important thing is always making sure that it's really good if you know lots of stuff about scalability, but make sure you're actually answering the question that they're asking. So in this case, it's an evaluation on the importance of scalability. So make sure, like I say, you're focusing on the importance and you're doing that evaluation. This is why it's really important to scale. These are the potential challenges we could face. That would be like an example of an evaluation. 1.2 then, so it's describe the use of computer clusters and distributed computing in data storage and management. Or the way I've written it out, it's describe what computer clusters and distributed computing is and where you would use them. So like I say, don't just tell us the use like the criteria is asking for. You need to kind of flesh it out a little bit more than that. So address them both one by one. What is a distributed computer system? Where would you see that used? Or you can give an example of your organization. You can say how you use distributed computing if it is something you use, which I imagine it probably is. And then do the same for computer clusters. Maybe there are some people sitting on the call that use computer clusters, but it is a lot rarer, so I wouldn't be surprised if no one does. But talk about those examples. So what are computer clusters? And then what are the type of the organizations that might use them? What do they use them for? So we talked about, medicine using them in machine learning and things like that. Aerospace for simulations, and have a look at what other examples you can find. If you do a bit of additional research, you can find lots of information on it. And then 1.3 then, describing the different dynamic storage models and where they would be used. So again, go through all 3, NAS, object-based storage, and hyperscale storage. Give examples of specific ones if you can. So you can mention Amazon AWS or Amazon S3 for the object-based one. And it's the same kind of format as this one above. Tell me what it is, and then tell me who uses it and why. So you could, again, talk about hyperscale storage, talk about those social media networks, and why do they need a hyperscale storage system? Well, because people are posting hundreds of thousands of things online every minute, something like that. Maybe look up the number before you say it, because I'm kind of plucking that out of thin air. That could be completely wrong. And Yeah, so that's basically the idea. What are they? Who's using them? Why are they using them? So you could talk Netflix obviously needs an object-based storage because their data is unstructured. 2.1, then it kind of mixes some of the stuff we talked about last time and this time. So you might need to refer back to last week's session to answer this one as best you can. But the criteria itself, just to make sure I'm reading the actual criteria as well, is to describe the impact of data type and data sources on data management techniques. So what you can do is look at different types of data, their typical sources, so you can compare structured and unstructured data, their typical sources, and then what tools can you use to store and manage each of them. So, we looked last time at data lakes, and we'll give you some example of data lakes as well, contemporary frameworks, those sorts of things. So to meet this one, talk about the structured and unstructured data, what are the differences between them, and then you can talk about, where they each might come from and what tool you might use to kind of work with it then, if that makes sense. So that'll cover that criteria. And then the last one then for this part one is 2.5. So it's explaining how data reduction can be used to increase storage efficiency and usefulness of data. Again, this is another one where you just need to make sure you're answering the actual criteria that's on here, because what a lot of people tend to do is they will tell me lots of interesting information about data reduction, which is fantastic, and I like to see, but they don't write anything about how it increases storage efficiency and usefulness of data. So obviously, best way to answer this, the way I've written out the question is describe what data reduction is and how it can be used to increase storage and efficiency of usefulness of data. So what is the general idea of data reduction? You can explain deduplication and thin provisioning, and then you can say how do those things improve efficiency and usefulness of data. So you can talk about thin provisioning reducing costs because you're not using data that so you're not paying for storage that you're not using. You can talk about data duplication saving on storage because you're getting rid of unnecessary duplicates of data. And for the usefulness of data, obviously going back to that deduplication, if you've got the same data set copied over and over and over again, if you go in and you want to do some analysis on some data, you're not going to know which one to use because you've got 17 copies of the same thing. If you carry out your deduplication, you've got one data set that you're working from all the time, then everything's consistent, everything's the same, you know where things is. And I'm sure you can imagine if you've got 17 of the same data sets and people are updating them all the time, you're going to eventually end up with situations where you've got a change on one that didn't make it into the other and things like that. So then you get inconsistent data as well. So that's how it can make it more useful, is by simplifying it, all the data in one place. As an analyst, if you know that there's one data set with all the information in it and you can go and access that, that's a lot easier than having, 13, 14, 15 of the same data set and then trying to work out which one is the best one to use in this particular scenario. So that's how we cover that one. So like I say, that is part one, and part one is focused on all of the management capacity, storage models, those types of things. Part two is all about the legislation and policies. So I'll just grab that one as well. Give me 1 second. Do have it open. Sure, it's this one here. Yeah. I'll make the text bigger in just a second. Okay, so outcome 3, all the criteria from outcome 3 is covered here. 3.1 is describe the types of legislation and regulations which impact on data storage and management. So the kind of advice I've given this one, describe exactly as it kind of says, and then I've given some examples of the information that you can use. The key for this one, again, like I say, make sure you're answering the actual criteria. So, it's all well and good having all the information on legislation and regulations, but make sure that you tell me the impact that it has on data storage and management. So, like I say, we all, I'm assuming, manage and store data to some degree as part of our role. So how does, if you want to talk about the Data Protection Act, how does the Data Protection Act change how you store and manage data in your role? Or the same with the Computer Misuse Act and the Official Secrets Act. What is the actual impact it has? So we need to make sure you cover. For 3.2 then, outline the content required for organizational policies and procedures for, and like I say, this is a 6-part criteria. So if you go in one file, these will be A, B, C, D, E, and F. So basically it's doing what I did earlier on in the slides. Look at each one and tell me what you would expect to see in this. So if you were looking at management, storage, and deletion of data, it would be things like who's responsible for management, who's responsible for storage, who's responsible for deleting data, how do we determine what data needs to be stored, archived, deleted, retained for a certain period, what are the retention periods, who deletes it after the retention period, different things like that. If data's archived, who's responsible for unarchiving it? All these different things. Another way you could look to answer this one, you can do one or the other, is you can look at your own organization's policies and you can explain what they outline. So I've had a few learners in this and they found it a really useful way to address the question, but they'll tell me, my quality assurance procedure says that the quality assurance process is that we need to do X, Y, and Z. We need to do that every so many months. That's carried out by this person or this team, and so on and so forth. So, like I say, you can either answer it more hypothetically, you can tell me the content you would expect to see, or you can tell me what's in your policies as part of that. So, like I say, have a look into it, see what the best way to answer it for you is. Different people find different things easier. So that's for that one. I just want to see if I've got any notes down here. Yeah, I say use the guidance slides given, give examples of how your organization policies cover some of the content. So it's a good way to do it. Again, if you can relate it back to your organization and things like that. Then we've got 3.3, explain the importance of organizational policies and procedures being up to date and well publicized. So again, I recommend that you talk about how your organization achieves this. How does it ensure that updated policies are distributed around the organization? But again, just make sure you pay attention to the criteria, which is asking you to explain the importance. So don't just tell me what your organization does, explain why it's important that they do that. So what are the potential risks of policies and procedures not being up to date? So think about the things I said earlier, like, it could be fines, could be legal issues, could be loss of money, could be loss of customer trust, that all stem from policies and procedures not being followed. I just think like the easiest way to kind of think about a question like this is imagine if in your organization somebody wasn't aware of a policy, didn't follow it, and as a result there was a massive data breach. What might come of that? And that'll kind of help you answer that question. And then the last one then, so 3.4 is evaluate the currency and completeness of organizational policies and procedures for data storage and management. So for this one, you do need to use, like I say, some sort of organizational policy, and you're reviewing it for those things. So what I've said is in my notes is, evaluate whether they are current. So current means up to date with legislation, technology, organizational requirements, and things like that. And then, complete means they cover all the necessary processes, roles, responsibilities, security, backup, retention, disposal, etc. So, look at your organizational policies and tell me whether you think they're up to date, they account for all the current, technology, current legislation or not, and tell me whether you think that they are complete, that they cover every area that they need to cover. One example for currency is obviously, a lot more organizations are using AI and things like that as well. So our policy was updated recently to tell us, how we could and couldn't use AI to make sure that we stayed within the various regulations around data and things like that. Like, I'm sure you guys are well aware of this, but obviously, if let's say, for example, one of you guys wrote an assignment, and then and in that assignment you've got your name and things like that. If I copy and paste that assignment and I put it into an AI model, that's a massive data security risk. So, or for example, if I wanted to analyze some of my learners' data to tell me, which learners I need to provide more support to, and I put it all through ChatGPT and ask it to work it out for me, that's a massive security risk because I've just put all of this sensitive information into that system. So it's obviously something that we shouldn't be doing. So that is something our policies will outline, is you can use AI for this, you can't use it for that. So that's obviously a change that would have happened relatively recently for most organizations. Whether it's a few years ago or some companies might be a little bit behind and done it a bit more recently, but that's something you can talk about. Is your policy up to date to account for things that are really new, like legislation, like technology changes, the advent of AI and that sort of thing. I've just realized I've got this in there twice, so I'll just get rid of that really quickly because it's this up here. So yeah, hopefully that kind of that makes sense because that's everything covered there. So yeah, again, like I say, two parts. The first part focused on different data storage models. So you're explaining to me about why capacity is important, what things like computer clusters, distributed networks, hyperscale storages, those kind of things. And then the last question is just on data reduction, what it is and how it's achieved and how it makes data efficient and usable. And then you've got part two then, which is focused on legislation and policies. So how do legislations impact how you work with data? What content do you expect to see in policies for X, Y, and Z? What's the importance of policies being kept up to date? And then, can you review your organizational policies and determine whether they're current, so up to date, and complete, so cover everything they need to cover? Is there anybody who has any questions about either of those assignments? I appreciate that I whipped through both of them then quite quickly and didn't have any break between the two. So any questions or any criteria that's not completely clear, or is everybody happy with all of that? Great. I'll assume that means that everybody's happy with everything I've gone over there. So like I say, we've sort of finished this session in really good time, come to the end of it quicker than I anticipated, to be honest with you. So we'll do the same thing that we did last time. If you want, it is booked in until 1, so it's only about an hour, but maybe, like I say, that hour is what you need just to get maybe some rough notes down or maybe make a start on this. So I'll send both of these documents over. It'll just take me a second to do that. And then like I say, if you want to hang around for an hour and complete some work, feel free to. If you just want to go and come back to it later, you can just go and come back to it later. And if you want to stick around and ask questions and stuff, you're free to do that as well. So, brilliant. Let me go ahead and stop the recording. So that's stopped now. I know some